before starting to the infrastructure as a code basic concepts and this part, the first thing is, suppose we have one application that requires some S3 buckets, it requires some EC2 instances, some databases to be connected, some VPC subnets. I'm talking about AWS environment in particular. So suppose I want to deploy my application over these environment, and this application require a lot of resources like EC2 instances, S3 buckets, databases, VPC, subnets, NoSQL databases, monitoring tools, and all these and many other services. So for these deployment and for creating these infrastructure, suppose if we don't have infrastructure as a code concept, so what we'll do, we'll just go to AWS console, we'll configure each and every service over there using this management console GUI. We'll go to S3 bucket, we'll fill up the complete form, we'll fill all the configurations, we'll fill the bucket policies, we'll enable the public access and public denial policies, we'll check for versioning. Everything we have to do manually over the graphical user interface in AWS environment. So this is a very hectic process, and if suppose we have to use dozens of services, dozens of resources in AWS cloud or in any cloud platform for our particular application, we have to configure every service manually. So this is a very hectic process and a time consuming process, and sometimes the services that we are creating might not good with the intercommunication between them. So to resolve this type of issues, to resolve these conflicts, we have infrastructure as a code, as a technology or as a concept. What happens in infrastructure as a code, we'll basically write or manage our infrastructure in configuration files, and we'll deploy or we'll run those configuration files using some tools, so using some infrastructure as a code tool, and that tool will basically manage our infrastructure in cloud environment or in on-premise environment. So in infrastructure as a code, we'll write our infrastructure in code form, we declare every configuration that we're required to have in our cloud platform or on-premise that will be needing by our application or software product, and that infrastructure as a tool will read those configuration, will process it and take some decision based on those configurations, and will deploy or manage our infrastructure in the cloud platform or in on-premise platform. So this is the basic concept of infrastructure as a code. Basically, we are just dealing with the infrastructure in a code form. So we don't have to use graphical user interfaces. We don't have to use CLI for cloud providers. We just have to write the basic script for an infrastructure management and deployment, and the tools will take care of every management task that we have to do related to those infrastructure that required by our software application or any product. So this is the core concept. Now, infrastructure as a code could be used for both on-premise or for cloud platforms. So if you want to build or deploy any of your application over on your premise infrastructure, you can use tools for infrastructure as a code as well, and also for cloud services as well, like AWS, Azure, GCP, and all. Now, in infrastructure as a code, we have two type of approaches. One is imperative and one is declarative. What imperative approach is? Imperative approach defines like if we are writing or if we are providing step-by-step configuration details for an infrastructure, that comes under the imperative approach. In imperative approach, we have to define every step of infrastructure development, infrastructure management in steps form, in a workflow order. And in declarative approach, we'll just define the end state, the end infrastructure that will be required by our application. And in declarative, we don't have to write our infrastructure in steps form. We don't have to manage the workflow or the work order for our infrastructure. The tools will do that automatically for us. So these are the two approaches that are available in infrastructure as a code. One is imperative and one is declarative. So in this session, we will look upon Terraform and CloudFormation. These two tools that are there for infrastructure as a code are based on declarative approach. So we'll just define the end state, the end resources that we're required for our application, and these two tools will internally manage the workflow for creating those infrastructure in our cloud platform. So let's move forward from here. Coming on to the next slide, why we need infrastructure as a code. So as I told you, like suppose if we have to create or deploy our application infrastructure over the cloud, and it includes multiple resources like VPC, subnets, and we have to create multiple EC2 instances, virtual machines, multiple databases, NoSQL, SQL databases, and load balancers, or maybe S3 buckets, some monitoring tools. So to create all these resources in a single go using GUI or using command line interface is very hectic. It might take days to create that infrastructure in a proper manner, and in future suppose we have to manage those infrastructure again, it will consume a lot of time and a lot of resources to manage those infrastructure. Now in every product development we have multiple environments. We have different environments like dev, testing, staging, prod, and whatever. So like to build this infrastructure for every environment is again a very hectic process, and it's very time consuming, and it's very cost consuming as well. So infrastructure as a code allow us to write all the configuration in a single file and manage it for different environments, manage it for different resources and services, and for different cloud providers as well. So we don't have to worry about managing configuration for a particular service for a different environment. We just write the configuration for a single environment and we can deploy it to the multiple environment using a bit of changes in environment variables. So that's why we this infrastructure as a code is very less time consuming. We just have to focus on the configurations for our infrastructure. It will increase the DevOps speed, the development and operations that we have to perform for our project or for any application. It increases the speed for that. The infrastructure that we are creating should be consistent throughout the environment and in other environment as well. So one of the services that I'm creating for my pre-prod environment should be similar to the service that I'm creating in the production environment. So using this infrastructure as a code concept, we can maintain the consistency as well throughout several environments. Also, it will reduce the cost, as it will save a lot of time. It will save a lot of resources for creating the infrastructure manually. It will reduce the cost as well. So these are some benefits that are there for infrastructure as a code. Moving forward with this, so these are some common example for infrastructure as a code tools. One is the most renowned, that is Terraform. We have Chef, we have Ansible, we have Puppet, and AWS CloudFormation. These tools are most renowned and most widely used in current market or in current scenarios. Terraform is one of the platform or one of the tool that can deal with cross cloud deployment as well. Like we can deploy our resources in multiple cloud platform. So suppose our application might be required the virtual machines from AWS environment, and it requires some storage account from Azure environment. So we can do this cross deployment as well using Terraform as a tool. I'll show you later how we can do that. We have some demos in line. I'll show you those demos, how we can use Terraform and deploy our cloud resources across the cloud platforms. So these are some examples. Now moving forward from here. So this is the basic picture or the workflow, how infrastructure as a code work. So basically we'll generate the templates, we'll write the templates for the configuration of the resources that we required in our cloud platform. And then we'll process those templates. The tool will create a script out of it, the deployment script, using some policies that will be that will be particular for any of the cloud platform. Like AWS requires some access policies to deploy our infrastructure. So using those policies, this script will work, and this script will be delivered to any of the tool, maybe Terraform, Ansible, Chef, or Puppet. Then this tool will take care of those scripts and those templates that we have generated or the configurations that we have written. And according to those scripts and configuration, it will create a network, it will create the applications, it will create the storage accounts, security, secret vaults, and the overall cloud infrastructure. So this is the basic part. Like, we don't have to manually create any of the services in cloud platform using GUI or using CLI part. We just have to write the configurations in a single file, and in a single go we can create all the services parallelly in a cloud platform. So this will save a lot of time for us. This will save a lot of cost for us as well. So coming on to these different tools, so every infrastructure as a code concept, or every application deployment has 4 steps. First is the initial setup of our infrastructure, then to manage this infrastructure for further use, and the application setup over that particular environment, or over that particular infrastructure, and to manage our software application. So taking an example, suppose I have to create one backend application using Lambda functions and API gateways, serverless backend application. So the first task would be to initially set up our infrastructure, like creating the Lambda functions, creating the proper API gateways. Then to manage them, suppose I have to add some of the APIs later on, remove some of the APIs later on from our infrastructure. We can do that as well. And then the application setup, the actual code setup, configuring our Lambda functions to use databases to serve the database, to serve the data to the end user using the Lambda functions code that we have written. And at the end, we have to manage those applications. We have to refactor the code. Maybe we have to add some more APIs. So these are the 4 steps that is majorly required by any of the application. First is to set up the infrastructure, then manage it, set up the application at first step, and then manage the application. Now, if you talk about Terraform, so Terraform is good to handle for the initial infrastructure setup, for managing the infrastructure, and to have initial application setup as well. But Terraform won't be able to manage the applications in the flow. So Terraform is limited till initial application setup, whereas this Chef, Puppet, and Ansible could not be able to do the initial infrastructure setup, but they are able to manage the applications later on. So this is the difference between this infrastructure as a code tools. So generally, most of the organization, what they do, they use a combination of Terraform or Ansible, and in that way they are able to achieve all the 4 steps from initial infrastructure setup to application management level. So these are the common difference between the infrastructure as a code tools. Moving forward, coming on to Terraform. So Terraform is one of the most widely used infrastructure as a code tool or technology for infrastructure deployment across the cloud platform. So Terraform allows you to write your configuration in human readable format, and it will basically manages your infrastructure lifecycle. So you just have to write your configurations in HashiCorp language, that is HCL. So HashiCorp, Terraform is a product from HashiCorp, and HashiCorp has its own language for writing the infrastructure configuration. It's more similar to the JSON format. It's evolved from a JSON format only. So I'll let you know that as well, like how to write a Terraform script. We'll see that later on. Now, this Terraform can manage your infrastructure across multiple cloud platform as well. Like you can use Azure, you can use GCP, you can use AWS in parallel, and you can deploy your infrastructure or resources across the multiple cloud platform in a single go. Then Terraform basically uses state management. So it will track your actual real world state of your cloud infrastructure or your application infrastructure, and it will compare it with your desired or required infrastructure, and based on that it will create a workflow and deploy your applications to multiple cloud platforms. Then we can use version control system as well with Terraform. We can deploy our code to GitHub or Bitbucket, and then using CI/CD pipelines, we can run Terraform scripts and deploy our infrastructure. So Terraform basically helps this agile method of software development using CI/CD pipelines and using GitHub or Git platforms, version control systems. So it will basically support the DevOps part as well. It is a part of a DevOps. We can say Terraform is one of the service that comes under the DevOps technology, and it will allow you to build your infrastructure and application using GitHub and CI/CD pipelines. So this is a kind of an overview what Terraform is actually. So it's infrastructure as a code tool where you just have to write your configurations for infrastructure in JSON kind of format, that is an HCL format. And once you will run your Terraform script, the Terraform will take care for your workflow, how to create the infrastructure in a particular cloud environment or in a cloud platform, and it will deploy all the desired infrastructure for you. Moving forward from here, so Terraform basically has 4 major steps. One is to init, that is to initialize Terraform in your working directory. Then you have to run Terraform plan command, then Terraform apply. So Terraform apply will deploy all your infrastructure over the cloud platform. And once your platform is ready, once your infrastructure is deployed, and suppose you don't want to use it further, you can use Terraform destroy command to delete all the infrastructure or all the resources that you have created. So in the first step, basically you will write your Terraform configurations in .tf files, and the Terraform will use the state file. The combination of your Terraform configuration.tf files and the state file will be served to a core, a Terraform core, and over the Terraform plan command, it will compare your desired configuration and the current state of your infrastructure. Based on that, the Terraform plan command will create execution flow, the execution pipeline, how your services or infrastructure would be created, what kind of resources you are going to create, and what resources would be updated, on how many resources would get deleted. All the execution plan you can check with Terraform plan command. And at the end, once you are good with Terraform plan command, you just have to simply run Terraform apply, and it will deploy the desired execution plan that you have created over the different cloud platforms. So this is a working architecture for Terraform. It will collect the configuration that you have written. It will check for the real world scenario state. Then using the Terraform plan command, it will compare both these and create an execution plan. Once that execution plan is ready, you just have to apply it. And in the apply state, it will create or build the infrastructure or resources based on that execution plan that is generated. Once all these resources are created, and if you want to destroy, delete or remove the infrastructure from your cloud platform, you just have to run Terraform destroy command. So it's very simple using Terraform to create your infrastructure and your resources over the cloud platform. Moving forward, let me just quickly walk you through some Terraform basic things. Just give me a second. Okay. So in Terraform, we have several terminologies like providers, variable outputs, modules. So I'll walk you through all of these. So first, going through the files and the architecture, how a Terraform module or a Terraform code look like. So here is one of the example. We can see this one. So you can see I have created several .tf files. Each of the .tf files have some configuration settings for some of the resources. For example, I want to create an IAM role in AWS environment for Redshift Spectrum. So this is a resource block, and it will tell how to create or what configuration should be there for this particular IAM role. So this is how basically we create one Terraform configuration file. Uh, if you are starting fresh with any of the Terraform file, you first have to create a main file. So main.tf, it will be the primary file that you will create. And in the main.tf file, you will basically put all the initial configurations that are required. This is one of the Terraform module. So we don't have to check for this one. I'll show you the different one. So yeah, this is the main file. The uh, the scratch file that we have created. In the main file, will basically uh, define the Terraform configuration, like what would be the provider. So providers are basically the cloud platform or the cloud service providers that are available in the market. For example, AWS, Azure, Kubernetes, or GitHub is one of the cloud service provider as well. GCP is one of the providers. So Terraform basically supports hundreds of or thousands of cloud providers that are currently available in the market. So in the first block, you just have to mention the configurations for your Terraform script, like what would be the version of your provider, from where it should have to pull the provider settings and all those things. And the later on, we are providing a provider block. We are configuring a provider block. In the provider block, we'll basically set up our provider configurations. For example, in AWS, which profile will use for the deployment. So the default profile, that means I'm going to use my default profile for AWS CLI to deploy all the infrastructure over the AWS account. Then which region we are going to use. So we are using US East 2 for the cloud infrastructure deployment. So these are the provider settings, like the AWS settings. So profile will basically allow you to use AWS secret credential and access secret keys. And using that, the Terraform will be having the access to create and build your resources in AWS environment. Later on, we have one variables.tf file. In the variables.tf file, we'll mention our all the variables that will be used during the runtime of our this Terraform scripts. So I have created two variables. One is tags and one is bucket name. So using this Terraform script, we are going to create one S3 bucket in our AWS environment. So for that, I have created two variables. One is the bucket name and one is the tags that will be required in the text setting for our bucket, S3 bucket. Then we have the output file. The output file will basically show the output blocks. And in the output blocks, we can mention all those parameters that will be required as an output once this resource deployment part is done. So output part is kind of a block that will basically return you the parameters and the actual values that you can use in for further resource development. So for example, once this S3 bucket is ready or is deployed, I want to collect the ARN for this S3 bucket. And this is how I'll basically fetch the ARN for my S3 bucket. So these are the output variables or the output blocks. Now coming on to the actual S3 bucket resource code that is written in this s3.tf. So you can see first part is to have a resource. So resource tag will show this is gonna be a resource block. The first part of this resource will tell you which particular resource we are going to create. So it says in AWS environment, we are going to create S3 bucket. So this is fixed. This is defined by in Terraform only, like what particular resource you want to create. Now this is the logical name with which you want to create a resource in AWS environment. So it will tell like we have to create a resource, and the resource will be AWS S3 bucket. Its logical name would be S3 bucket. And what will be the bucket name, with which name you want to create a bucket. So here I have fetched or given the configuration for the bucket name, and I am using my bucket name from the variable that I have defined in variables.tf. So basically the default bucket name is this one, Terraform demo Devesh. We are going to create one S3 bucket in AWS environment with this name. And we are using this variable over here in the bucket name part. We have declared one more variable with tags. So I'm using this variable tags over here and configuring this tag variable for this S3 bucket. So this simple 2-line of code will create one S3 bucket in your AWS environment whenever we'll run the script. Now for the configuration, these are some optional configuration that you might or you might not require. So this another source will basically tell we are going to create one ACL for our S3 bucket. So this ACL will basically allow the public read over our S3 bucket. How we have used this one? Again, we have used this as a resource tag. This particular resource will tell what thing we are going to create or what resource we are going to create in AWS environment. So it says AWS S3 bucket ACL will be configured from this block. Again, we are using a logical name. So using this logical name, only these three resources are communicating with each other and they are linked with each other. If I'll just change my this logical name, then this resource block will points to a different service or the different resource that I have created or that might be available in AWS environment. So we have to keep the logical name same if we want to link all these three resources with one another. So using this block, we are going to create one ACL, and in ACL, we are just telling like we have to publicly allow this public read for our S3 bucket. Now the third part is to configure the bucket policies. So this is the policy that I have written to basically allow all the get object actions over my S3 bucket from for this particular resources. So this will basically again the same thing. We have to mention the resource tag, and in the resource tag we have to mention what basically what resource we have to create. So again we are saying AWS S3 bucket policy we have to create, and for which one? For this S3 bucket logical name. So this S3 bucket logical name is coming from here. Then for which bucket we have to mention? I have mentioned the same bucket ID. So how I reference this one? So we already have created AWS S3 bucket resource, and for that S3 bucket, this is the logical name and then the ID for it. So this simple piece of code will create one S3 bucket for me. It will create a bucket policy into it, and it will allow the ACL to be publicly read. Now, the first thing is how I'll run this configuration, Terraform configuration file, and how this script will going to create the resources in my AWS account. So the first thing, the very first step is I'll just run this Terraform's init command. So what this Terraform init command will do, it will check for the main.py file. It will check for this Terraform block, and it will again check for what provider we are going to use. And based on the provider, it will download or install all the configurations that are required by this provider to run or to build our infrastructure. So Terraform init will basically initialize the Terraform into this particular directory, and it will download the configurations for a particular cloud platform provider. So as soon as I'll run this init command, you can see it is initializing the provider plugin. It is fetching the AWS provider from some repository. It will install all the configurations for AWS provider, and it will create one of the folder over here that will contain some log files and some configuration files for our S3 resource, for our S3 provider. Once this plan command is done, we can see some of the lines, and those lines will basically tell like we have successfully initialized your provider and Terraform in your current directory. So this plan command is done. Now you can see we have some files available. One is this look.hcl file. This will basically tell who is the provider and what hash keys we are going to use to decrypt or to basically read this encoded file for our AWS provider that we are going to use for our infrastructure deployment. If we want to have multiple cloud platforms, we just have to mention it over here. Like if I want to use GCP, I just have to put a GCP its source from where we have to collect it and its version number. And I can use multiple cloud platform as well for a single Terraform script. Once this init command is done and we have initialized this Terraform in our directory, we have to check for Terraform plan command. So this Terraform plan command will basically gives the execution flow or the execution plan for our resources, like how it's going to create the resources. As soon as I'll run this Terraform plant command, you will see we'll be having one of the Terraform state file available in the folder directory. So see, we have this terraform.tf state file available. As we are running this Terraform's plant command for a first time, that's why this terraform.tf state is empty, and it got deleted once we have that plan available. So in the terminal, you can see we have this whole Terraform plan command execution plan, and it will tell like how it's going to create the resources and what resources basically it will create in my AWS account. So it will create S3 bucket. First, it will create a S3 bucket with all these configuration that is mentioned here. After that, it will create this bucket ACL with all these configurations. And once that ACL is created, it will create the bucket policy. So this is the Terraform execution plan for our S3 bucket deployment. And at the end, it will just print the output for ARN and the bucket name. So this is going to be our Terraform execution plan. Let me show you my AWS S3 bucket. You won't see any of the bucket available right now with the name Terraform demo Devesh. We are going to create one S3 bucket with this name, that is Terraform demo Devesh. Let me walk you through. So this is my S3 bucket console. Right now, I don't have any of the bucket with that particular name. As soon as I'll run that Terraform apply command, those resources or that particular S3 bucket will be created over here. So let's quickly start the terminal here and run this Terraform apply. So once I'll run this Terraform apply, again, it will give me the execution plan, and it will take a permission from me whether to create or whether to build these resources over my AWS environment or not. So I just have to write yes, hit enter, and this Terraform plan will basically create one of the S3 bucket in my AWS environment. You can see it's in creating status. Once this creating part is done, it will create one S3 bucket in my environment. So let me refresh it. Yeah, so you guys now can see I have this Terraform demo Devesh bucket available. And as we have allowed the ACL public read access, that's why one warning we can see over here for publicly access. And as we have mentioned our region to be US East 2, it is deployed in US West 2 region that we have mentioned in our main.tf file here in the provider settings. So this is how we can create any of our infrastructure, any of our resources in any of our cloud platform. This is an example for creating one S3 bucket in AWS cloud environment using Terraforms. So basically, we have to arrange our Terraform files in this output in this manner only, in this architecture only. There would be one main.tf file that will hold the basic configuration for our providers and for Terraform. Then based on the resources, whatever resources we are creating, we have to create one TF file for that particular resources. We have to create a separate file for variables that we're going to use in our script, and a separate file for output part. So this is the best practice to use Terraforms. It is not mandatory to have this type of folder architecture. We can keep all this code in a single file as well, and this will work the same. It won't create any issue. But the basic norms or the best practices, still we have to divide variables, outputs, and resources and in different files particularly. So you can see we have this Terraform state available now. So this Terraform state file will basically is the real world state file that we have in our AWS environment. This will basically depicts that what all resources we have in AWS environment would be reflected over here. So you can see we have created S3 bucket. It has these configurations. It has S3 bucket ACL with these configurations and bucket policy. So this is the state file that Terraform will use to compare it with our desired configuration, and it will create the resources in AWS environment. Now, suppose I want to update my S3 bucket. I want to, I don't want to have this particular ACL block. I'll just comment it out, and I just want to update this one. And also suppose I want to add few more lines into my policy. So I just have to go over here in the statement. I'll just update it. Suppose I want to deny this use case in my bucket policies. Previously it was allowed. I have updated it to deny. Now these updates I have done for my S3 bucket, and I want to deploy these changes to my AWS environment. Then again, I just have to run this Terraform plan command. It will give me the execution plan, like how the Terraform will going to update my resources in AWS environment. It will give the entire plan for it, and then I just have to run Terraform apply command. So in Terraform apply command, it will basically tell or it will basically update all the resources that I have updated in my execution plan. So you can see we have some red marks and some yellow marks. So basically red marks will tell what all things would be destroyed and what all things would be updated. So as you can see, yellow mark is for update in place and the red one is for destroy part. So we are going to update it in place, the S3 bucket, and we are going to delete all these permissions that we have given for the ACL part. We are going to delete the whole ACL resource that we have mentioned there, and we are going to update our bucket policies. So this is the execution plan. We are going to change 2 services, 2 resources, and we are going to destroy 1 resource. So this is the overall plan that we can see over here. Now I just have to run this Terraform apply, and it will make all the changes over there. So Terraform really makes the infrastructure deployment very simple. You just have to mention your resources or your infrastructure in configuration format, and you just have to run this plan and apply command, and that's it. You are ready to deploy. You are ready to have your infrastructure available in your cloud platforms. Again, I have to give a permission to approve, and then it will update my S3 bucket. So as soon as I run this or I updated my S3 bucket or the resources, it created one backup file as well. So the backup file will basically gives like what was the previous state, so that if you want to have a backup for our previous resources that we have destroyed or removed, we can just recreate or rebuild or undo the steps for the infrastructure deployment using the backup files. So you can see apply is completed, 2 changes, 1 destroyed. If I move to my S3 bucket, you can see I'll be not be having that ACL part now, that public read access is removed. And if I'll go to my bucket policy, you can see it is updated to the deny one. So this is how we can just change a bit piece of our code and we'll deploy our resources. So now coming forward or moving forward from here, suppose we have to deploy this application or this script to the production environment. We have to move the script to the production environment for production use cases. So for those production use cases, we can't keep our Terraform state file over here, and we could not be like, it's not a best practice to push this file to your GitHub account from where you are running your CI/CD pipeline. So for production use case, it's recommended to use any of the cloud repository where you can put your Terraform state file, and Terraform will pick the state file from there. So it would not be disclosed to any of the user in real scenarios. So to move this Terraform state file to any of the cloud platform or to a secured location, we just have to update our main file and the Terraform block. Inside this Terraform block, we just have to add one backend block. How we can add that, let me show you. So if I move over here, so this backend block we just have to add over there after the provider block. And this will basically tell like where we have to keep our Terraform state file. So if I'll run my Terraform plan and Terraform apply command, Terraform will create one state file in S3 bucket in this particular region and into this particular bucket. So in that way, we can keep our Terraform state file more secure, and it won't be disclosed to any of the end user, and no one can replicate or check for our resource configuration that we have deployed. So for production use cases, we have to keep this Terraform state file to be secured. So this is the other part. Now, suppose if you want to have multiple resources with same configurations to be deployed in your AWS environment. So for that, you can run loops as well in Terraform. Terraform support conditional statements and loop statements as well. Let me show you how. So over here, you just have to check for the resources and meta arguments. So using this for each loop and some other settings, you can basically iterate over a single resource, or you can create multiple resources with the same configuration by writing a single piece of code. So for each will basically allow you to iterate over a particular resource and create multiple same kind of resource in any of the cloud environment. So this is how you can use for each group and another group. You can basically create this particular resource multiple times. So this is one other thing. We have one concept of models as well, modules as well. So modules is kind of packages or third-party resources available in Terraform. So just like in Python or in any of the programming language, we can use third-party modules or packages that have some Python code or Java code or whatever language you are using. Based on that, we can use modules as well. Over here, we can define our own modules, and we can use these modules at any places. So just like in Docker, we can create one Docker image and push it to the Docker repository, and we can use that Docker image at multiple environments. Like that only, we can create Terraform modules. We can push out the Terraform modules to Terraform registry. We can make them public or private, and we can use it at multiple places according to our requirement. So Terraform has multiple modules pre-built available, just like we have multiple Docker images or many Docker images available in Docker registry, or that are like by default available. Like that only, we can have multiple modules available in Terraform. So you just have to go to the registry part. Over here, you can search for any of the module or any of the provider and its documentation. So this Terraform registry will give you the whole code and the piece of documentation that you can go through, and you can apply it to the any of the part. So suppose you want to create or build any of the AWS services, you just have to check for this AWS documentation. This will give you the documentation for every service. Suppose you want to build some Lambda function, just check for Lambda. Over here, you can see we have multiple resource option. Suppose I want to create AWS Lambda function, and you can find the example usage and every parameter that you can configure according to your requirement in this document. So Terraform document is quite helpful. We can have options for modules as well. If you want to check for any pre-built module available for any of the provider, you can check for that part. So suppose I want to use a pre-built VPC module, I can just directly use this module, and you can see the code snippet as well, how you can implement your module in your Terraform scripts as well. So let me give you, so these are some modules that are deployed over Terraform registry. If you want to have some modules on your local as well, you can keep them like this. For example, this is one of the Terraform project that I have done in my past. It has several modules for different pipelines, for different pipeline applications. And we have two environment, one is prod and QA. So suppose I want to deploy my infrastructure to my QA environment. So for that, I have created this main.tf file. Inside that, I have mentioned the state file path and all the modules that I want to deploy to my QA environment. So basically, each of the module will represent one of the module that I have kept over here. For example, if we check for this pipeline UEMPL claims, you can see we'll be having it available over here, this one. So this module is basically using this piece of Terraform code, and we are deploying Lambda functions, IAM roles, Glue, CloudWatch, Redshift for this particular pipeline. So this pipeline is one of the module that we have kept over here, and we are deploying it using these Terraform scripts. So every Terraform module has one main file, one variable file, and services file. Like for Redshift, we have this piece of code. For Lambda, we have these resources and configurations. For Glue scripts or Glue jobs, we have used this ones and all. And to keep our source code, we have one folder available here. So here is the actual Lambda function that will be deployed over the AWS environment using this Lambda Terraform scripts. So in the source code part, we have mentioned the path for our Lambda function here, and we are using it in here in the resources part. So this will basically check for the source code from the source folder. It will read the Python script and it will deploy to the Lambda environment according to these configurations. So this is how we can deploy our all pipelines to a single environment in a single go. So if I want to deploy all these modules, all these pipelines that we have inherited over here, I just have to move into this QA repository and I have to run Terraform plan and apply command. And it will fetch all the configuration from these modules and it will deploy to my AWS environment. So this is how basically we actually deal with the Terraform in real world environment or in real projects. So this is a bit overview about Terraform. If you guys have any questions still here, you can surely ask. Yeah. Any questions still here? I hope it's clear to everyone. Okay. All right, then let's move on to the CloudFormation part. So as we have Terraform as one of the tool available, we have CloudFormation as well, but CloudFormation is limited to AWS environment only. Uh, we can only create or provision the infrastructure in AWS using AWS CloudFormation. We cannot have cross cloud deployment practices available using CloudFormation. We can use some of the third party cloud resources like GitHub or some other, but not like GCP or Azure or that we have in Terraform. So in CloudFormation, we can model or provision or manage our resources within the AWS environment. In CloudFormation, we have to create our scripts in JSON format or in YAML format. So basically, we'll write our configuration in YAML format or in JSON format. We'll deploy it to the AWS CloudFormation, and the CloudFormation will run those files as a stack, one CloudFormation stack or CloudFormation template. And based on those configuration, it will deploy the resources in AWS environment. So it's similar to Terraform only, but it's limited to the AWS part only. And we have to write our configuration in YAML or in JSON scripts. CloudFormation can support multiple regions deployment. It can also support multiple AWS account deployment as well. So if you are using multiple AWS accounts and you are deploying your infrastructure into multiple regions, CloudFormation would be a good choice for AWS infrastructure deployment. So let me walk you through the CloudFormation console as well. So here is that one. So currently I'll be having two CloudFormation stack to deploy some Lambda functions and one Node.js application in Lambda. So if we check for this one, these are the settings. So in CloudFormation, we mention every configuration file that we have written or every template that we have written for resource deployment as a stack. So we'll basically create one stack that will include multiple CloudFormation template, and that stack will be executed by the CloudFormation during the runtime, and it will create the resources out of it. So if I'll show you the template for this particular stack, you can see we have these CloudFormation settings available over here. We can build and create our CloudFormation template in this designer as well, where we can just pick our services, drag and drop to the work area, and we can build those. So yeah, this is the template. We have two options. One is to use JSON, one is to use YAML. And you can see in JSON, we have just created resources, that is hello from Lambda function. We are creating one Lambda function resource in AWS environment. From where we are going to pick the code, we are going to pick the code from this S3 bucket. So this S3 bucket would be having some Python files or the code files that will be deployed to this Lambda function. And these all other settings like memory size, what IAM role will be required for that one, what will be the runtime environment. So we are using Node.js for this one. What would be the maximum timeout limit and all these. Then once we have this code for AWS Lambda function, we are creating IAM role as well for this Lambda function. So the type is IAM and we are creating it for Lambda function role. Then what all policies we can accept or deny, we can put it over here. And once we'll run this stack, this CloudFormation will create one Lambda function in my AWS account with this permissions and with this IAM role attached to it that is mentioned in the template. So you just have to create a CloudFormation template like this in YAML or in JSON file. To check for the proper syntax, you can again go through the AWS CloudFormation documentation, where you can find all the syntaxes and parameters that are required for a particular resource. You can implement it and you can deploy it. So this is similar to again to Terraform, but it's limited for AWS environment only. Let me walk you through one more template. Okay, so this is the other one where we have these services to be created. Let me zoom in. So we are creating S3 buckets, we are creating Lambda functions, we are using GitHub repos, we are using source event bridge, S3 artifactories, and multiple services to be used in this particular template. So how these services will be deployed, we have configurations for all over here. These are the configurations. First, we are creating the variables, some configuration that will be used by the template, like who will be the GitHub repository owner, where will be the source code of the bucket, and what will be the connection ARNs. Then from here, we are starting with our resource tags. So first we are creating CloudFormation IAM role. And this is how we have declared the CloudFormation IAM role and settings for it. These are the policies that will be attached in that particular CloudFormation IAM role. Other than that, we have some more resources below, like, yeah. So here we are using code build, AWS code build, and this will be deployed using this configurations, like with these environment variables. So this is how we can set the environment variables as well for our resources and all. Then we are using code commit repos. That is again one of the service in AWS environment, and we are deploying it. So this is an overview about CloudFormation. We can build and deploy our services in AWS environment from here as well. So this is it. If you guys have any questions, you can surely ask.